so much for the opportunity to speak. And first of all, I'd like to thank to Trevor and his team for this great organization. I love being here. I mean, this is a great organization. Today, I'd like to take a look at the operational efficiency and sustainability from cargo tank coating perspective, which is one of the most overlooked area. As many of distinguished speakers mentioned in the morning session and here, shipping faces growing tension between operational efficiency and environmental pressures. Ship owners are trying to catch up with the demand for cutting greenhouse gases, complying with IMO and regional rules, and as well as charter sustainability demands. While the reality on the ground, as for all businesses, is a little challenging. Constant search for reducing costs, optimizing vessels' employment, and reducing the costs, as well as you want to do this with as fast as turnaround time. And not to forget, all needs to be done in a very, very competitive market. Then next question is, what are those challenges that cargo tank coating can become relevant and can play a major role for improving efficiency? First one is cargo profile complexity. Need for switching cargoes far from the less aggressive cargo to very, very aggressive cargoes to or high-spec cargoes. The cargo commodity is constantly changing and the requirements is getting higher and higher. Extensive cleaning requirements, increasing demand for high purity standards and resulting prolonged cleaning times, and naturally consumption of chemicals, water, and in other words, spending a lot of money. Stricter standards for tankers on performance monitoring for cargo tank coatings. Again, it's coming back to international and regional rules that is getting tight and tighter every day. And looking on supply side, there's a very limited new building slot. Squeeze coating application time, again, is one of the most overlooked area. There is always pressure on the cargo tank coating application time, regardless of whatever the other works is being done in there. Where cargo tanks coatings decisions come into play? First stage is, of course, the strategic fleet design stage or new build stage. In this stage, main consideration focuses on vessels' market versatility versus capital cost, CapEx. Any decision here will determine charterer attractiveness and earning potential of vessels. And docking stage. Even if it might have been proved that the initial stage decision was wrong, there is another chance to change the coating. And in this stage, it can change the trade pattern of the vessel. However, off-hire costs, downtime, and the application costs. These are the main considerations. Owner and operator priorities. I'd like to wrap up a little bit here what we have discussed so far, because in next couple slides, I want to touch base a little bit technical details, and I promise it's not going to get boring. I'll finish quick that part. For owners and operators, first thing is operational efficiencies. I mean, needless to say, business exists to make money. No question asked. Environmental pressure, increasing international and regional standards, charterers' demands, as well as financiers' demands as well. This makes cargo tank coating decision even more strategic and operationally critical for ship owners who wants to adopt profit with purpose approach. It's very important to consider at this stage. Four important factors for the decision is that flexibility in cargo carriage, in other words, versatility, fast turnaround. It is crucial to the operations. Discharge, loading, cleaning, everything must be in a fast turnaround to optimize the employment of the vessel. Proven life cycle performance and regulatory readiness. And next three slides, again, is a little technical, but I'll be quick. What are the important things about the coating properties? ADR, coatings absorb, desorb, and recovery is try to come back the initial stage, what we call is recovery. ADR properties of coating will determine turnaround time and cleaning efficiency. Here on your left hand, there is a group that high absorption and very low desorption coating and long recovery. It means very slow turnaround and cross-contamination risk. This is the most dangerous risk. A chemical tanker owner doesn't want to face this one. You can basically contaminate the cargoes with the previous carried cargo. In the middle, high absorption and also high desorption, which they can claim that we can absorb, but we can desorb fast. Here is the problem. Cross-contamination risks still exist in very, very high degree. And also consumption of chemicals and water. In other words, the cleaning effort is tremendous. On the right side, we have virtually non-absorption coating and no recovery time, basically no downtime. Very fast turnaround, less cleaning. This is the simple demonstration of how it looks like the higher crosslink and the low crosslink coatings on your left, and the real images from the coating on your left hand. The coating with a very, very loose crosslinks, as you can see, and on the right hand, higher crosslinks, very dense. The trick here is chemical molecules is bigger than the crosslinks. It can't permeate. Here is finally we have arrived at the point that let's see the numbers and justify what I was trying to say. In other words, show me the numbers. So we have a case here with the MR tankers, MR23, with 16 tanks. We are trying to clean these tanks from ultra-low sulfur diesel to methanol, which is going to be quite challenging operation because we need high purity wall wash standards for this. Requirements is depending on the terminal we want to load, but it's usually the wall wash requirements. We have zinc silicate and high crosslink coating, polymer coating on the right hand. And tank cleaning time 64 hours versus 16 hours. And hot water cleaning time 56 hours versus 12 hours. Cleaning consumptions 3,200 liters versus 0. Here I want to highlight especially the hot water cleaning time because it directly translates into fuel saving. In next slide I'm going to show. Reduction of fuel cost by 3%, which is quite conservative number. These numbers we are getting from people, real operators, ship owners. Average carbon content of marine fuels is 86, and CO2 production per ship is 140,000 to 160 per ton, metric ton per year. And 300 fuel savings translate into CO2 reduction of 4,500 metric tons. These are quite substantial numbers. The last thing I would just want to say that, again, cargo tank coating is really there and it can contribute to efficiency while also can contribute to sustainability. Profit with purpose. This is the approach we're taking in this. Thank you.